Okay, so we've been talking about atoms in class, and so therefore we've been using the periodic table. But now in this video we're just going to talk about why it has that shape that it does have. At the bottom right here is the link to the video that I showed you in class today. Offer is still on the table. If you memorize that song and perform it, you will get extra credit points. It's also posted as a link on the class website, so you can always look there for help. So let's get started with the rest. So first off, we have the periodic law. So we've kind of been talking about this, but we haven't quite put that name to it yet. So periodic tells us that elements are arranged by increasing atomic number. So if we start all the way over here, hydrogen has an atomic number of 1, which tells us, if you remember, it has 1 proton. Next, we have helium with 2, lithium with 3, beryllium with 4, 5, 6, 7, 8, 9, 10, and so on. So they go in increasing number. And each element has a unique number of protons. That's how we define an element. We define it by how many protons it has. So therefore, every element of the same, or every atom of the same element is going to have the same number of protons. So every single oxygen atom going to have 8 protons. So if you see an atom with 8 protons, you know it's oxygen. Same thing, lithium. Every single atom of lithium will be defined in 3 protons. So that's the periodic law. That's what that tells us. Next we have what are called periods. So each row in the periodic table is called a period. So rows are the ones that go across. So if you look at a periodic table, there are 7 periods, so 7 rows going across. The spot at the bottom, there's 2 at the bottom, that's actually just to save space. Really, those go up with the rest of it, but it would be really, really long for that periodic table, so we put them below. So technically, there are only 7 periods. And the number of elements per period varies based on the number of electrons and energy levels. So we've been talking about Bohr's model. In Bohr's model, we know there are 7 possible energy levels, and it corresponds to how many elements are in a period. So that first energy level on Bohr's model right here, if you remember, has 2 electrons that it can hold. Elements in period 1, 2. Okay, so we have hydrogen and helium, so there's 2. Another example, that second period has 8 elements. Our second energy level can hold 8 electrons. So if you ever forget how many electrons can fit in a certain energy level, you can cheat and count the elements on the periodic table. So you just think, oh, how many go in that 4th energy level? Count them. 18. Okay? So that's a really cool little trick for the periodic table. Next we have columns. Those are actually called a group on the periodic table, so they go down. We have 18 main ones that we talk about, but there are a total of 32 groups. The elements in those groups have similar properties. So similar electron configuration, which we're working on, and that means that they are going to react with similar other elements. They're going to have similar properties. So that's really important. Groups have similar properties. Okay, so we have 3 ways that we classify elements. So we can classify them based on their room temperature. That would be our first way of classifying them. So if they're a solid, a liquid, or a gas at room temperature. In the classroom, when we use the textbook, if you look at the writing in the book, solids are written in black, liquids are in purple, and gases are in red. The only change, if you look at the classroom periodic table at the back of the room, is that the liquids are color-coded as blue. So if you had a periodic table in front of you, which you should because we've been making them, you'd be able to realize that the 2 liquids on the entire periodic table are only mercury and bromine. So we only have 2 liquids. Everything else is either a solid or a gas. So that's the first way of classifying. Second way is that we can divide elements as to whether they occur naturally or not. So if you're looking at the periodic table, those that do not occur naturally, that are man-made, are in white text. Okay. Otherwise, if they're in the other colors, they occur naturally. So every single atom or element with an atomic number greater than 92 does not occur naturally. So they're only man-made elements. In between, the only other ones would be technetium and promethium. Those do not occur naturally either. So that's our second way of classifying. So we have whether they're a solid, liquid, or gas, and then if they occur naturally or not. Our last way is based on their general properties. So we can classify things as metals, nonmetals, or metalloids. We'll go through each of those now. So most of the elements that you're going to look at are metals. So they're represented by a blue box in your book, and many of you, when you did that personalizing the periodic table, colored those in blue as well. So these are the types of elements that are good conductors of electric current and heat. So if you think back to when we were talking about heat transfer, and you felt that cold metal spoon, you knew that was because it was a good conductor of heat. Metals, good conductors of heat and electricity. Most metals are solids at room temperature. The only one that is not is mercury. And that's actually a liquid at room temperature, which is why we use it in things like thermometers. So those are some characteristics of metals. Next we have nonmetals. So these elements are basically the opposite of metals. They're poor conductors of heat and electric current. So they don't do that very well at all. They're represented in the blue and the yellow boxes, in the book, and also probably on your personalized periodic table. Most of them are gases at room temperature, but they do have others that are solids, and they have the liquid bromine. So if you look down at the bottom here, it shows you the ones that are gases. So you can see most of them are red, so most of them are gases. But then there are a few solids and, of course, one liquid. And our last little thing we're going to talk about are the metalloids. So these ones are kind of in between metals and nonmetals. They're not quite metals, they're not quite non-metals, so we call them metalloids. So they have the ability to heat and electricity sometimes. So this kind of depends on the temperature, and it depends on the element. So if they're in extreme temperatures, they might be able to conduct that heat or electricity. Very cold temperatures, maybe not. So again, that depends on their temperature, and they are represented in the green boxes in your book, maybe on your periodic table as well. So that's it for today. So make sure all of your notes are filled out. Write down any questions you have so we can go over it in class tomorrow. And have a good night.